Okay, so this is the first practice paper up towards Easter mocks. I'm going to try and do this all in one go, and then on the video try and make links inside the video at the right times. That might not work, it might just be one long video that you're going to have to fast forward through. So this is the higher. I think Mr. White's going to do the foundation, so if you're looking for the foundation paper, go find that video from Mr. White. It will be on our YouTube channel anyway, but here we go. So I might make mistakes. I've done it already, this paper, so I'm hoping to make it nice and smooth and try and explain things really clearly. I've got this right makeshift recording studio. I've lost my stuff I borrowed, let's say from science. So let's see how it goes. So, question 1. This is a calculator paper, so we're looking to use the calculator whenever possible. Okay, they're not going to give you any credit for doing anything by on your own, so non-calculator, so there's no point with that one. So let's have a look. So normal price of a watch is £80 in 2 shops. Now, it would be good. I'm not going to do it throughout the paper because I don't really use the highlighter, but it's really good to pick out the information. So there's £80 in 2 shops. These are 2 shops, obviously. Both have a sale. In times, the normal price of the watch is reduced by £18, so we're going to have to figure that price out. And in seconds, the normal price of the watch is reduced by 20%. Which shop is selling the watch for the cheapest price in the sale? So let's just sort of label what we're doing. So we've got times, and they're doing an £18 reduction. So we've got £80, take away £18, gives me £62. So that's in that shop. And the other one, we're doing a 20% reduction. So as it's a calculator paper, I am going to use multipliers. So it's going to be reduced by 20%, which gives me 80% of the value. That is 0.8 as a multiplier. You can put 0.80, but you don't need to. 0.8 is going to be used. So all you do is take the price, £80, they're called multipliers for a reason, and multiply by 0.8, and that'll give you 64. Okay, so there's the price of that shop, there's the price of that shop. Which shop is selling the watch for the cheaper price? The answer is times. It's written out times is cheaper, just so they know exactly what I'm responding to. But I can't just put this, I have to have this evidence. So that is basic percentage reduction. Okay, very straightforward. If you don't do it this way, that's absolutely fine, but this is used in multiplier way. Okay, question 2. Question 2 is about plotting graphs, so it's about finding the values first. So we've got x cubed minus 6x plus 4. There's the table of values to fill out. Now, because it's a calculator paper, I'm going to use my calculator really well. Okay, I'm going to make sure that I don't have to think too hard about this. I just understand what to do. Okay, so what I'm going to do is, this is actually like a calculation for me. So where there's an x, I'm going to put an empty set of brackets, and that can go in my calculator just like that. What we have to do is put the values of x in the place of these empty brackets. So put them in the empty brackets, and it'll work out the missing value. So just doing this one, so write that out, empty brackets like this. Now what I saw some of you do when I've looked at your papers, you're working these out in your head and you've got it wrong. It's calculator paper, so I'm expecting to see these just placed in like that. Okay, and then literally type it in exactly like that. Use negative for negatives, so that negative button which is there, let's put that in. Cubed, I'm literally typing as it says it, so minus 6, minus 2, so remember to use that. If there is a problem with your calculation, all that will happen is that it will go back, it will say syntax error or something, and you can press the left button and edit your calculation. So it's 8. Next one, all I can do is go back and replace it for zeros. So this will be 0 cubed minus 6 times 0, add 4, which will be 4. But just to show you, you can just delete them out of here. Okay, so you've got 4. And then the last one is to use 1. So 1 cubed minus 6, 1, 4. So let's go back, delete that. So that becomes minus 1. Just double check that. Yeah, that's fine. Okay, so that's nice and straightforward with a calculator. Non-calculator, you'll just have to work this out. So minus 2 cubed is minus 2 times minus 2 times minus 2. And you have to work it out very carefully. So I'll just literally be writing this out slowly. working out bits by bits, that'd be minus 8. Minus 6 times minus 2 is plus 12. Add 4, and then I'd be working out like that. Okay, and I'd come to the same answer. Okay, so it'd be 8. Anyway, this is calculate paper. Next bit, been quite lenient here. They haven't asked you to draw a line across it or anything like that, just want to plot it. So this is how it's going to go. These form your coordinates. So the first coordinate is going to be minus 3, minus 5, x, y, that's how you do it. And then minus 2, 8, minus 1, 9. You just go in pairs like that. Now there's nothing stopping you writing out your coordinates like that before you get going. If you can't remember that these are where your coordinates come from. I'm just doing it so you can see kind of what the coordinates are going to be when I do it, because you won't be able to see the top of the table when I start plotting them. Okay, so I'm going to plot those coordinates. So the first one is minus 3, minus 5, so that's in the middle. It's in the middle of here, so I'm going in the middle of the square. I've not done a good job, it should be a tiny bit lower, so it should be in the middle of that square. Next one, minus 2, 8, so minus 2, 8, which is there. And this is a cubic graph because it's got a power of 3, so it should be this sort of S shape on its side like that. Okay, minus 1, 9, so minus 1, 9, again it's in the middle, so I'll do this one a little bit better hopefully. Next one, 0, 4, so you can see it's coming down and then it'll go back up. Minus 1, so 1 minus 1, so again that's in the middle. 2, 0, and 3, 13. Okay, so you've got to really try to get this curve done properly. Do not use a straight line, and you can etch it out with the pencil and then confirm it if you want to. I'm just going to go for it. Okay, and you can see I don't know where the base of that is going to be. I don't know where the height of that is going to be. I'm just doing it rough. I'm trying to make it a smooth curve as possible. This cardboard that I'm using is sort of making it difficult, but there we go. So that's what it should look like. Okay, so that's drawing a quadratic or a cubic graph. Nice and straightforward. Right, next one. Now this could be in all different types of subjects, different questions, but this is basically a Pythagoras question. The reason I know I've got two sides, I've got to find a missing side. It says work out the length df, which is this one. It says it's a right angle triangle. Now right angle triangles could be Pythagoras or trigonometry SOHCAHTOA, but because there's no angles involved and it's not asking or talking about an angle, it's definitely Pythagoras. So Pythagoras, let's write it there in case you want to use it. To Google it or bang it on Maths Watch, is a squared equals b squared plus c squared. Basically, you square the two short sides and add them together and it makes the longest side squared. Okay, so df is the side I'm after squared equals, I always do the biggest number first, 6.8 squared, add 5.2 squared. It doesn't make a difference this bigger number first now, but when you're taking away it really does, so just get used to putting the biggest number first. So df squared equals, and all you do is just type in your calculator, 6.8 squared, add 5.2 squared, got that, 73.28. Okay, and then that is not the length of this side, this is the length of this side squared, so some big area over here or something. So to make it just a length, I'm going to square root that. And the examiner's looking for the square root, so even if you mess this calculation up and take away, you'll get credit for this following up part. So df equals, and because it's in these calculators already, press square root, press equals, automatically puts it in. So I've got 8.56037 blah 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 blah. Read the question. It does say give your answer to two decimal places. So decimal points there, 2 places there. It's either 8.56 or it's 8.57. This number that's the first to go is how you decide that is less than 5. So it's going to stay down, it's going to stay as that, so 8.56. On the whole, set 2 did very well, but again I understand that other students will be watching this. Key things, biggest number first. I know it's two short sides because they're on the right angle. If there was a side here, I'd take away. Okay, so that's basic Pythagoras. It will be hidden away in most exams in another shape, so just be aware of that one. Okay, so there we go. Right, next one. This one, I'm going to do as a tree diagram. You don't have to, but the reason I like tree diagrams is because it encourages you to use the probability laws, the AND law and the OR law. Okay, so what I'm going to look at here is Seb has a biased dice, which means it's not right. So it won't land on the equal amounts on the different numbers. It will land on one number more than the others. So when the dice is thrown, the probability it will land on a 6 is 3/5. Seb's going to throw it twice. So that's where it leads me thinking I could do a tree diagram, so I will. Work out the probability that the dice will land on a 6 on the first throw and not land on a 6 on the second throw. So you don't have to do all this work at all. You can just literally multiply the two things together. But I like doing these because, like I said, it encourages you to think about what you're going to do with the actual probabilities. So for some of you, you won't need to do this. For most of you, I would encourage you to do it. So landing on a 6 is 3 out of 5. So no 6 is going to be 2 out of 5. And they're looking for that, looking for you to understand that. When I roll the dice, it doesn't mean that the dice is going to change. It's going to be the same one. So these aren't going to change either. So let's say I hit a 6 and I roll it again. The probability of getting a 6 is still 3 out of 5. And no 6 is still going to be 2 out of 5. And exactly the same down here. Even if I didn't get a 6 the first time, when I roll it again, the probabilities are still the same. So 3 out of 5, no 6, 2 out of 5. And with tree diagrams, without thinking, immediately what you're going to do, like instantly, is write down these values here without even thinking every single time, because what it does, it makes you multiply the two values. So when we go this way, we're always multiplying across. Okay, if that makes sense. We're going across, so we're going to multiply together. So 2 times 2 over 5 times 3 over 5. Get it all written down. Now some questions require more than this. This one, you really didn't need to do all this, but it's just going to help. So what we've got, 9 over 25, just times the tops and bottoms. And so we're done. Work out the probability that the dice will land on 6. So we're going 6 first, and then not land on 6 down here. So it's going to be this one. Okay, 6 out of 25. Okay, so I left it like that. I should put it in the box, but that's fine. Again, you didn't need to do all that, but if you are happy to set up tree diagrams, you are more likely to be successful on those types of questions. On this one, I could literally have gone, right, to actually get a 6 is 3 out of 5, to not get a 6 is 2 out of 5. For them to happen one after the other will be that times that. I could have just done this little bit here, all just by itself, and it would have been fine. Okay, but I'm trying to secure you maximum sort of marks on these types of things all the time, so that's why I went for the tree diagram. Okay, right then, so this one, it's a good question. I'd like to get these sort of questions out of the way now, earlier on in the sort of exam push season, so it's good to see these ones. So basically, it's a compound interest question. Invested £6,000 for N years, so you don't know how many years, at 3% compound interest. So that means it's going to be adding 3% every year. So you'll be having 103% more than the previous year. So that's what it looks like. So it's a multiplier, that is 1.03. Okay, that's the key thing that I saw some of my class missing off. They were just using 0.03. But that is the multiplier we're going to use. So there is 6,000 times 1.03. And normally there's a power here. Normally there's a power here. And what it wants to know is if it is set up like that, the power is the number of years. How many years will it take it to grow to that value? So we just have to keep going. So that's what's going to happen. You'll see now. So we do 6,123 times 1.03 first. So in the first year, I get 6,180. Obviously not enough. And all I'm going to do is keep going back and adding the power. So after 2 years, so that's times it by 1.03 squared. I'm not going to be lazy. I was going to be lazy then. I've got 6365.40. I'm just going to keep going, so I'm not going to say much now. I'm just going to keep changing the power until I've got it. So and I know I've done it already, so I know that the value is quite big. Yeah. Now, some people are not very systematic. They'll skip these steps. Okay, I understand why. But in a real exam, you want to show every single thing. And on these practice exams, they are real exams to me, because I can really identify if you can do it or not by doing this correctly. And I can see your thought processes. So take your time, don't be lazy, show every single thing, and it will be worth it. Because if you've just put the answer, I don't know how you've decided to go about it. I don't know if you're messing around with your calculator till it works, which is not very time efficient. Yeah, that's what we got. Is that where after yet? 6. So after 6 years, I've still not got it, but obviously I'm getting close. It's probably the next one, and then the next one. There we go. So 6,000 times by 1.037 equals 7379.24. That's what I was after. That's the value I've got. So it took 7 years. Okay, so the number of years is 7. So n equals 7. Number of years is 7. Okay, nice question. Okay, it's unusual where you have to you don't know how many it's going to be, you have to keep trying it. And it's really good to reinforce the multiply thing on compound interest. So it's the money times by the multiplier. The power is the number of years that you're going to keep it in the bank. Okay, nice and straightforward. Right, this one for my group in particular, it's a 2-pager, this one. Oh, what a pain it's on the back. This is a cumulative frequency graph. I know I haven't covered it yet, so it's going to be really worth you watching this video. It's nice and easy subject. There's nothing difficult about this one at all. If you did it in year 10, you'll find it quite a basic subject. I'm looking for a ruler, which I've used to prop up this camera, so that's not worked out very well for me. Basics of this is it could turn into a box plot. I could be asked to do different things, finding the median and so on, so that's what I'm going to try and do. I thought I was really well prepared, getting everything sorted. Now I can't find the ruler. This is going to be freehand. It should not be freehand, but a ruler sort of protecting my iPad from this grip that I've got on it. So, cumulative frequency graph gives information about the speeds in miles per hour 400 cars passing a speed camera between 7 AM and 8 AM in one day. So there's the graph. Sometimes you'll have the actual table ready and you have to work out the values and plot them, but this is not, it's already been given to you. So working out an estimate for the number of cars passing the camera at speeds of greater, that's the key thing there, greater than 72. So some people did this, but didn't do that part there. Okay, so 72, this isn't good. Okay, you should be using a ruler. So straight up, okay, from 72, that's where it is. It tells you where to go from. 72 miles per hour, it says miles per hour there, and there's 72. And then you've got to go directly across, so this is really poor. And I would not advise you to not use a ruler. Gets me to there. Okay, so what's that for me? That's 1, 2, 3, 4, so that's 340. Okay, but that's not the answer. That is how many cars travelled at 72 miles an hour, or up to 72 miles an hour. It wants to know greater than. It was up to 400, so it wants to know how many is trapped in here. So it's very straightforward. It's going to be 400, take away 340, so I've got 60. When I did use a ruler, I think I got something else slightly lower. I think I got like 50. I think the mark scheme says you can have anything between 50 and 60. So as long as you're doing it correct, you'll be within the sort of overlap that they allow. Okay. Right, then the next bit is, as I said it would be, it's linking it to a box plot. This information is going to come off the graph that we just did, and there's other information in the actual question to sort of give you bits for the box plot as well. Okay, so the speed of, the least speed of these 400 cars was 50. So on a box plot, if you look at this one, this is the least value, the lowest value. This is the highest value, the greatest value. Okay, this one is the median. This is the lower quartile, so that's the lower quartile. That's the median. That's the upper quartile. That's the maximum value. That's the minimum value. So they're things to know. And that's what we're going to use the graph to find. So the minimum is 50. You can choose whatever you want in terms of how big you want it to be. So I'm going to just do that for 50. The biggest one is 81. So just check your scale, it is going in ones. 81. Use a kilometre frequency graph and the information above to draw a box plot to show the distribution of these speeds of 400 cars. So I need to do the median, and it's always from this way. So when you're doing your box plots, it's always that way. So you're always coming this way in. So the median is in the middle. So if it's out 400 people, you can see it there, 400 cars, whatever. That's where the graph goes up to. Halfway is going to be 200. So we're going to go across and straight down. So I think the median is 66. Okay. So go to the scale, there's 65, 66 is there. Put it there. Again, ruler should be used. I've just not got one. The next one, we need to do the lower quartile, so it's the lower quarter. The median is halfway, a quarter is going to be at 100. So I'm going to go across, hit that, come down. I've got 62. So I'm going to draw a line at 62. And then I need to find the upper quartile, which is the 3/4 of the way up, the upper quarter, which is from 300. A nice way to do this is just 100 add 200 is 300 to find that. Sometimes they're awkward. Straight down. Got 70. So it's going to be 70. Again, this looks really shabby. You should be using rulers to get accurate readings off your graphs. So that's what I've got there. I've got the 2 box plots. Okay, so typically, normally, what you have to do is when you're comparing box plots, is you're going to compare the medians and the interquartile range. The interquartile range is actually the upper quartile take away the lower quartile. So the size of the box is actually the interquartile range. That is the interquartile range. And the smaller they are together, the smaller box, the more consistent that is. So from here I can see that the times between 7 AM and 8 AM are actually more consistent because they've got a smaller interquartile range. Medians allow you to compare on average who's quicker or faster or whatever. So the top one, you can see the median is further along because it's at 66 and this one's at 60. So I can say that on average these are faster because the median is bigger. Okay, so that's what I know. So when I'm doing a comparison, it's only worth 2 marks. These 2 marks must be about the median. I do mean must, and the interquartile range. So let's just bullet point these and make sure I've got it in. So between 7 AM and 8 AM, that's the first box plot. The cars were faster on average as the median is bigger. So that's a comment about the median done because it's further along. And I know that the interquartile range is smaller, so the time's more consistent. So I'm going to say something about that now. Also, the interquartile range is smaller, so the speeds are more consistent. Okay, if I didn't actually talk about what was going on, like the cars actually being faster, if I just said the medians were bigger, the interquartile range was smaller, without talking about the speed or the consistency part, I would only get 1. Okay, because it's looking for you to say it in context, which means talking about what's going on. Okay, that's worth 7, and it's well worth your time. If you haven't understood that, or if you didn't understand that before, it's a key one to learn. It's something I will be teaching. It's something that we rely on in the maths department to people to talk to know, and it's nice and straightforward to do. Okay. Right, the nightmare question. The one that takes ages to get your head around. When you get your head around it, it's quite straightforward. Okay, so I've done this already. So I'm going to get my notes so I don't make a mistake. I've already done the PDF. Well, I've already emailed it out, hopefully, to you, where I've already done it written out, which is this bit here, which shows you how I've got that. Okay, there are 2 approaches. So I'll go over it now. So there's 1 million gallons of water in a lake. A company's going to pump the water out of the lake. The company uses 4 speedy pumps and 5 flow pumps. One speedy pump can do 35 gallons out of the lake in a minute, and one flow pump can pump all the water out of the lake in 500 hours. Okay, so one pump can do it in 500 hours. The company wants to pump all the water out of the lake as quickly as possible, so it wants the best pump really. Should they use 4 of the speedy pumps or 5 of the flow pumps? Okay, so you've just got to organise your work clearly. Okay, so I'm going to do speedies on the left and flow pumps on the right, and just try and keep my thoughts together. Okay, so there are 4 speedy pumps, and each pump, so 4 of those, and each one does 35 gallons in a minute. Okay, so what I need to do is find out the same unit for all these pumps. So if I figure out how many hours speedy is going to take to empty the lake, and find out how many hours the flow pumps are going to take to empty the lake, then I can compare which one's the best one. Okay, so let's have a look. So there are 4 pumps that do 35 gallons per minute. So that's 140 gallons per minute. Okay, we want to know how long that will take to empty these 1 million gallons at that rate. Okay, so we have 1 million, and when you want to know how much or how many of one thing takes, that means you're going to do the divide. So we want to know how many of those fit into this, so we're going to divide it by 140. Okay, and that is going to give me 7,142.857 blah blah blah, and I'll just leave it in my calculator so you can see that. So 1, 2, 3, 4, 5, 6 divided by 140, that means I've got this, and it's better to leave it in your calculator. So that is how many minutes it's going to take for these pumps to empty that out of the lake. 7,142 minutes, but I'm not going to compare them in minutes, I want to compare them in hours. So what I need to do now is turn those minutes into hours. Okay, so we know that there are 60 minutes in an hour, so if I want to figure out how many 60s go into that, again, I'm saying the word how many, I'm going to do this 7,400, I'll do it as a mixed number because it's in my calculator like that. I'm going to divide it by 60, as this turns it into hours, so that's how we turn it into hours, because there's 60 minutes in them. So I'll show you there, so divide by 60, I get roughly 119 and 21st, sorry, of an hour. That's how many hours it takes the speedy pumps to empty the lake. Okay, that's the complicated one. The other one is you've got one flow pump takes 500 hours. You actually have 5 of these. So if you've got 5 times more, so 5 pumps, 5 times more, it's going to be 5 times quicker. So we can divide that by 5, and this will take 100 hours. So all these are called speedy pumps because they've got 5 of these. It's going to be better for them to use the flow pumps. So we've got to respond. I'll show them all working hours, they're clear. You can see that's there, so that's 100 hours in total. That's 119 hours and a bit in total. Now I've just got a comment. Should they use 4 speedy pumps or 5 flow pumps? So they should use 5 flow pumps. And just to top it off, you say it is 19 hours quicker. It shows you know what you're looking at. Okay, but you could just have flow pumps as your answer down here, and that would be the backup that you were needing. Okay. Right, this one. Spacecraft travels from Earth to Mars at an average speed of 18 kilometers per second. The spacecraft travels a distance of 1.4 times 10 to the 8 miles. It's in standard form. It doesn't matter because you can just put it in your calculator. calculate the number of days the spacecraft takes to travel from Earth to Mars, and it's giving some conversions. Okay, so I can go the really long way about this. There's probably easy ways to do this, but there we go. So I've got a unit of speed that's in kilometers per second. That's dealing with kilometers. And I know my distance in miles. I've got a conversion here, which tells me how to convert a mile into kilometers. So what I'm going to do is I'm going to convert my distance into kilometers so I can use the speed with it. I can't use them at the moment because they're in different units. Okay. Calculate the number of days the spacecraft takes to travel from Earth to Mars. So it said I've got a speed, I've got a distance, and it's asking me for a time. So it's a speed, distance, and time question. So I'm going to write that down. So speed equals distance divided by time. Okay, you can draw the triangle if you so wish. Okay, but I'm not going to. Converting it from a mile to a kilometre, I'm going to multiply. You can use this bottom one if you're going to turn the kilometres into miles that way, but I'm not. So I'm going to turn this distance, which is 1.4 times 10 to the 8, and I'm going to multiply it by 1.6 to turn it into kilometres. So that's the miles getting turned into kilometres. That's what's going to happen there. So there is a way to put standard form in your calculator. It's 1.4. Where is it? Where is it? I've lost it. Oh, there you go. Exponent e, which is this one here, and then just put the 8. Okay, then you can calculate with it. There's nothing wrong with typing it as you see it. So that means the amount of kilometres I've got for miles is 22460, so 224 million. And that's my distance in kilometres now. So I can use that with this speed that's also in kilometres. Okay, so speed equals distance divided by time. I'm actually going to calculate the number of days, so I need to actually know what this is just for time. Okay, so speed equals distance over time. So I need to make time the subject of this equation. So these actually, I'll multiply by t and then divide by, so I'll show you that. So I'm going to multiply by t, so speed times time equals distance, which is good to know. But I'm going to divide by the speed, so time equals distance divided by speed. This is where the triangle is invented, so you don't have to know this bit, okay, but understand how to manipulate this is good to know. It's going to come in handy for rearrangement purposes of other equations that you'll be given or formula you're given. So time equals distance divided by speed. So I've got my distance of 22460. I'm going to divide that by 13 kilometers per hour, or per second. Okay, so there you go. Divide by 13. And I get this humongous answer, which I'm just going to leave in the calculator. So I'm just going to write a bit of it down now. So 17230,769.23. I'll say a bit of it, I wrote it all down. But that is seconds. Okay. The question does not want seconds, and the reason I know it's seconds, by the way, because this says it here, that says per second. It actually wants me to have it in days, which I underline there. So the first thing is we're going to turn this value into, let's write it down, we're going to turn this into minutes by divided by 60. So divide by 60 turns that into minutes. So I'm just going to write divide by 60 there. So that's minutes. Then I'm going to turn it into hours. There's 60 minutes in an hour. So divide by 60 again. So I've got this value. But that's hours. I don't want it in hours, I want it in days. So then I'm going to divide by 24. Turn it into 119.430 blah blah blah. Okay, and so That's my final answer in days. Doesn't discuss rounding, just calculate the number of days. If we did it as whole days, we could say 200. You could write down the whole value unrounded, and it'd be absolutely fine. Okay, so that one is quite tricky, and I've noticed this idea of conversion between minutes and days and so on coming in a few questions. So this process of changing it's important. The difficulty at the start was that they were in kilometres and miles, so different units, so I had to change them into the same unit. So there's a bit of understanding going in there. As you can see, they've given you the conversions question, so I could just use it. Okay, right, so already 35 minutes, I'm on question 8, so it's about a third of the way through. So hopefully I can just keep plodding along. Hopefully I do spend the time and make sure the video links to the different questions you want. If you've seen this question and you can see it's right, skip through it. Okay, don't waste your time watching the video for hours, and it was a waste of your time. Okay, right, I can tell me my tea as well. The graph shows distances travelled by a lorry. So you can see time along the bottom, distance at the top. Work out the gradient of the straight line. So that's fine. Gradient. This is gradient. We're going to do the rise over run. We're going to draw a triangle. So that's what we're looking for, a triangle. And try and make it a convenient triangle. Starting at 0, 0 is fine. And just look for a point where you've got some whole values. It doesn't really matter. Oh, it's a calculator paper, it doesn't matter at all. So you could go up to 10, along 10, and up to here. You could go along to 20, that's not really convenient. There's a whole number there, it doesn't matter. So I'm going to go along to 10, along here. So I could do my triangle, this could be my triangle here, right here. I don't know why I went along, it's just so I could read it off clearly. So the distance along here, it goes up to 10, so that's that width, that's the run. And it goes up to, what's this then? So got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so it's got up in twos. So 2, 4, 6, 8, 10, 12, 14, so that's 14. So the rise is 14 over a run, which is 10. You can put it in your calculator. You can have it as 7 over 5. You can have it as decimal, doesn't matter. I'll go with a decimal. The gradient is 1.4. Okay. Write down a practical interpretation of the value calculated in part A. The gradient on a distance time graph, you can see I've done my distance divided by time. Distance divided by time is a speed. So it's the gradient actually is the interpretation is actually the speed that you're going at. Okay, so 1.4 is the speed. So it's 1.4 minutes. Oh, sorry, to get it right around, kilometers per minute. And the reason I know I've just got kilometers there and minutes there. Okay, so 1.4 kilometers a minute. So the gradient is the speed. Okay, reverse mean, set 2. Not very good at this one, but after this question it should answer a lot of questions about reverse mean. It is very straightforward. You just got to have a certain way of thinking about it. 50 students did the test. The mean for 50 students is 8.4. So actually, every kid of the 50 got roughly 8.4. So we can work out the grand total from that. So that's what I'm going to do. And that's the reverse mean idea. You've got the mean. Normally you would add and divide, but I know what the mean is. So I'm going to multiply the answer with how many people I've got. And it tells me that it was actually 420 marks in total for these 50 students. There were 30 boys. The mean of the boys was 8.25. So 30 of these kids have got 8.25. So I can multiply those. 30 times 8.25. I've got 24. Sure, that's not right. No, it's not right. I did this when I practiced it. I've got the zeros. It's 247.5. That's the total for the boys. Work out the mean for the girls. So at the moment I know what the boys got, I know what their average was, their mean. I can work out the total for the girls, so if I just do 420 take away my answer. So 420 take away my answer, which was 247.5. I get 172.5. That's the girls' total. And now it's actually just a standard question, a mean question. The reverse mean's done. I've multiplied to find the original totals. And now I know the total for the girls. To find the mean for them is just as normal. I know the total. This is what they've got all together. So I'm going to divide that by how many girls are left, or how many girls are in the question. There's 30 boys, so there must be 20 girls. So I'm going to divide that. Okay, so I've got 8.625. They were nice, easy questions. 3 marks. It didn't really take me 3 minutes there. Nice and straightforward. 8.625. There's no real must watch video, which is just solely reverse mean. You just have to watch the averages clips to actually get a sense of the whole subject. But essentially, you multiply and take away instead of adding, then dividing. Okay, nice little questions to learn. Simultaneous equations. We can't start the simultaneous equation because there's no coefficient, no number on the letters that's the same. For some reason, I target these ones all the time. Okay, and we're going to multiply by the opposite number. So that means the top row I'm going to times by 5 because that was here. And the bottom row I'm going to times by 2 because that was what's here. Okay, that was what's on the top. Okay, so you do the opposite. Okay, so we'll rewrite these equations and multiply everything out. So 25x plus 10y equals minus 10. If you're not sure, use a calculator. What's that? 6x minus 10y equals, well, my brain's not having it today, 22.4. This is what you got to do, especially when you're stressed. Not like I'm stressed, but you will be in your exam. Just check it. Took me a minute. It means I'm not going to use any mistakes later. Now I can actually deal with this because I have the same value, the same coefficient on the letter. So we're going to try and add or subtract these. So I'm going to write down stop. You can see it there, so stop. If the sign is the same, we will take away. If the sign is the opposite, we will add them together, we'll plus them together. So you can see that the sign is opposite, so we're going to add these together. These, we're literally going to cross out. They're going to be eliminated. That'll make 31x equals minus 10 add 24. Of course, you can do it, but I want you to just use your calculator. That's going to be 12.4. Okay, so we have changed the equations. We've eliminated one of the letters, and now we can solve to find one of the letters. So I'm going to divide by 31. Again, so divide by 31. And that gives me x equals 0.4. It's unusual to have a decimal, but as it's a calculate paper, so be it. That's where it's going to be. We found one value. We're now going to try and find the other one. The way to do that is always to choose one of the original equations. I always go for the top. So 5x, I like to show which one I'm using, equals minus 2. And that is going to be substituted into the x. That's where it's going to go. So 5 times 0.4 add 2y equals minus 2. Use your calculator. 5 times 0.4 is 2. Non-calculator, you do 4 times 5 is 20. Move decimal point back. I'm just going to bring it up here so it's a bit clearer. I don't want it to be colliding. Draw my line. I'm going to get rid of this one first, so I'm going to add 2. 2y equals 8. It's because I brought across a minus here. I'm not thinking clear that one a minus. So that means this is a minus. So I'm going to take away 2. So minus 2 take away 2 is minus 4. And I'm going to divide by 2. So y equals minus 2. And you can tell I'm not clipping the video or anything anymore. Before I just do that again, but I'm not. I'm just going to show you how it sort of flows naturally. So x equals 0.4, y equals minus 2. What you could do to check if you got it right, if you just think about one of the other equations you didn't use, so 3x minus 5y equals 11.2. This is always a good thing to do. If I put these values in that I think that they are, it should equal 11.2. If it does, then I've definitely got it right. So 3 times 0.4 take away 5 times minus 2 11.2. I've definitely got it right, so I can move on with confidence, and it's one of those things that you can know, you can rely on, that you understand. So now I can tick it off, I've got it right. Okay, bounds. Bounds can start off very simply, but this one they've just been a little bit mean with this bit here, and I'll explain why. Normally, you just write down the value, you go one below, one above, or whatever. This one, it's saying it's been rounded to the nearest 0.5 of a mil. So you have to go 0.5 above and 0.5 below, which would normally that kind of be the bound really, but it's not. Now we have to go and find the bound between them. Okay, so if you're not too sure, the way to find a midpoint, the middle of something, is add them and then halve them. It's the most effective way, it's the easiest way, you don't make any silly mistakes. If it wasn't the case, I'd make that a sort of 50 in my mind, and it would help me sort of think about it. Div 1. So there's your lower bound and your upper bound. So 19975. Okay, so that is the lowest possible volume of that cup. So the machine puts tea and milk into each cup, so tea and milk is going to go into this volume that we've figured out. It puts into each cup 175 mils to the nearest mil, so I'm going to do the upper bound for that and lower bound for that. 24 mils of milk is measured to the nearest mil, so we're going to do the same on that one. Is it possible that the total volume of the tea and the milk is going to be greater than the volume of the cup? So they're going to tip this milk and tea in, okay, and they're saying, is it possible that it's going to overflow? Okay, so let's have a look. So we've got 175 mils to the nearest mil, so I can go 1 mil up, 176, 174, go halfway, 174.5, 175.5. And then 24 mils, I'm going to go 25 and 23, because that again, that's just the nearest mil, so it's 23.5 and 24.5. And what you've got to do with bounds is really think about what's going on. So it's saying, is it ever possible that when we combine these, that it will be greater than the possible volumes? So this is the smallest the volume will ever be. So we're going to keep that. That's the figure we're looking for. If we can make these figures bigger than 199.75, we've proved that it could overflow. Okay, so what we're going to use is the lower bound for this one. So we'll keep the lower bound for that one. We're going to use the upper bounds for these because we're adding them together. And if we add two upper bounds together, we'll get the maximum value. So I'm going to do 175.5 add 24.5. Which is 200. So theoretically, it is feasible that it could actually overflow. So is it possible that the tea volume is greater than the volume of the cup? Yes, is the answer. It's possible. You don't have to justify anything else. You can actually see there that that'll do it. That should be clear enough. Okay, question 13 of 21. So keep plugging away. We got 48 minutes. Now, I might pause the video and do another one because the size of the video might be difficult to upload to YouTube, and at least you've got it in 2 parts then. So that's what I'll do because it's going to make it easier for me to upload the video.